All right, so we're going to be deriving the equation of a circle, and after today you should be able to derive the equation of a circle when given a circle with a center point and like either a radius or a diameter, of course, and you'll be able to spit the equation out in what we call radius center point form. Okay, so let's get right to it. It looks actually not too complicated and fairly intuitive once you understand how it all comes together. Okay, so we have a point. All right, but first, before we get all to it, I'll just go ahead and show you what the equation is. All right, so we have start with the equation. So the equation is the radius squared equals 2 points squared. All right, and that one set of points is x minus h and y minus k. All right, so that is the radius center point form of a circle. Now, I want you to ask yourself, what does it kind of look like to you, right? And maybe it'll all come together. Like if I joined this into these two into like maybe an A or a short leg, right? And this was like a B, and maybe this was a long leg, right? And maybe we turn this into a hypotenuse. Right, you might say to yourself, hey, that looks really close to or identical to Pythagorean's theorem, right? Because that is how it is derived. So you might be like, how in the heck do I get a circle equation from a triangle equation? I don't get it. Well, hopefully you'll understand after the next, 20 minutes or so. It's actually fairly intuitive and makes a lot of sense after you really understand it. So here, let's have I start with this point set here, and I start with this point. And I know that this point here, I'm on a lot of black ink, so I'm going to use orange, I guess, for this one. So this point is, what is this point coordinate? Well, on my coordinate plane, it's 1, 2, 3, 4, 4, comma, 1, 2, 3. It's 4, 3, 4, comma, 3 is this point coordinate. And then I'm going to be like, okay, well, let me pick another point, and we'll say that it's, I don't know, like maybe 3 over and like 4 up, 1, 2, 3, 4, like there. And I would ask you, well, how would I figure out that point? And without counting from the origin. What would that coordinate point be? Well, it's pretty easy. I can just take my value here, and I just know that I moved 1, 2, 3, 4 up. I moved 4 up. So my delta, right, and my delta y, like that, is 4, and my delta x equals 3. I'm just writing it like that to save some space on here, right? So if my delta x is 3 and it started off as 4, that means that this is 7, and that it started off as 3 and it went up 4, means that this is 7. So this point is 7 and 7. Okay, well, that was pretty easy. I didn't have to count all the way back here. That's pretty convenient. But what I don't know right away is the short line distance, or the straight line distance between those 2 points. I mean, I can figure it out pretty easily, right? Because this here is a right angle. This is a right angle right here. So I can be like, okay, well, this is 3. This absolute value is 3. The length of these, so this is going to be 3 squared plus 4 squared is 25, and then take the square root of that, and this is 5. Right, that's Pythagorean's theorem. Right, so in case you missed that, no, my hypotenuse here, my hypotenuse equals square root of 3, the square root of 3 squared plus 4 squared equals 9 plus 16 equals square root of 25, which equals 5. That's the carpenter's trick there. 3, 4, 5 triangle. Anyway, so that is the length, straight line distance, of my blue triangle there. Now I'm going to make a little red triangle here. And a little red one, and let's make it the same distance away. Okay, I'll put it like right here, I think. Just happen to know that that is the point that I need to be at, right? And I look and I'm like, okay, well, this is 1, 2, my change in x is -3, but it's still 3. All right, my delta x, my change in x is still 3. It might be -3, but it's still 3. I wrote delta 3. My change in x, although it's -3, it's still 3, right? And my change in y, although it's -4, it's still 4. Change in y equals 4. So these are the absolute values of my change, right? Which is, I guess, is another way to say why I put it in the block, right? That's what I'll start telling people, I guess. So x, absolute value of x equals 3. All right, yeah, that's why I'm doing it. Anyway, so again, 3 and 4 are my legs. So therefore, my straight leg, my straight line distance between the two will be 5. Is also 5. All right. So that's pretty cool. I made a staircase. That's neat, right? But what else is going on here? What other type of relationships similar to a circle do we have in here? Well, if you see here, what is the angle measure between blue and red? Well, that's 180 degrees. And what is the distance between blue and red as related to blue and black and red? Well, it's black. Black bisects blue and red from each other. So this blue and red is kind of like a diameter of a circle where blue is a radius and red is a radius. Okay, so if we take something like this here, and let's make what color should this one be? Maybe a purple. Blue and red kind of make purple. Where'd my purple highlighter go? Here's like a purple highlighter. Hopefully this is big enough, right? And I'm gonna this is probably big enough here. I'm gonna take this and I'm gonna put my center of my compass on my circle. I'm gonna slide this hole over top of my point, and I'm going to hopefully make contact. That doesn't make contact. I guess I'm gonna have to grab a different marker. How about this bright blue one? Maybe this bright blue one will mark. Nope, that one doesn't do it either. So how about we try? How about we just try a burgundy? Let's just do a burgundy. marks pretty good usually. Yeah, that's marking pretty good, and it's not slipping too much. Oh, it did not. Spoke too soon. Okay, that's not bad. I've seen worse. Alright, so there's my circle. It slipped a little when I was doing it, but that's effectively makes my point. Right, so that's my circle. Right, going through those, what I did was took that radius, and imagine I took the attached triangles of those radius, and I drug them around. Okay, I drug them around. And imagine to yourself, I'm dragging those triangles around. Maybe I can make a quick little triangle here. Real quick, I have this little triangle. Let me see, triangle. Where's it? Triangle like this. Right, I have this triangle here, and it's getting drug around like this, right? And while it's doing that, what is changing? Is the center point changing? No, center point's not changing. Is the point at the end of the hypotenuse changing? Well, of course, that's what I'm dragging. And how about this point? Is that point changing? Yep, that point's changing. So what about the difference between the length between this point and this point? Well, no, that's not changing because this point's not changing. What about the difference? What about the change between here and here? Well, no, that's not changing because relative to here, that gap is all staying the same, right? Because this is a radius like of a smaller circle, right? And that central angle here is staying the same. Right, so that's not changing either. This x value, if you look, would be staying the same too. It's just really just a rigid movement of this triangle. So no, this isn't changing either. Okay, it's just a rotation of this triangle, and this triangle is just rotating around this axis. It's rigid movement. So we know that from transformations, that this is not changing either, right? And this isn't changing either. Okay, so my delta x is staying the same, and my delta y is staying the same. All right, so in the form of Pythagorean's theorem, we can write this. We'll call this the hypotenuse. Well, we're not going to call that the radius. We'll call that the radius, because it is what it is. It's the radius. Okay, we're going to call this the radius. We're going to call this the radius. And in Pythagorean's theorem form, we'll use orange, I guess. Does it show up all right? The radius, oh yeah, that pops. The radius squares equals my change in my short leg, change in x squared, change in x squared, plus my change in y squared, right, for each one of these triangles. Okay, so the purpose of these functions here is to be able to plug in an x value or a y value. So if I come down here and I know that x is this, right, and plug in x, it spits out a y value, right, plus or minus y value, right? Or if I get a y value and I plug it in, it spits in, if I know a y value, it spits in an x value. If I know a y value, it spits in a y value, right, plus or minus, right? So I want to put this in terms of x or y. And you've seen that my variable is x or y. So I'm going to carry that through, and I'm going to say that my r squared, which is my hypotenuse, r squared is going to be equal to my x and my y. So what is it equal to? Well, remember that my delta x is a change in something. And if I'm referenced, I need to reference something. So I got to reference the center of my circle, right? Because the radius, right, it's going to say something on my circle, right, is going to be based upon my radius as compared to my center of my circle, right? I'm going to pick up my center, I'm going to drop it somewhere, right? And my point of interest, whether it's x or y, is going to be a reference from that circle, whether it's far from x or y, based upon Pythagorean's theorem, right? So it's going to be a change from my x value. So it's going to be minus, right? Because a delta is x. My x or y value is going to be x, comma y, right? So it's going to be x, and I'm going to get 2h. I'm going to call this, I can't call this x and y. I got to call this h and k, my center point, h and k. I have to call that something else. I can't call it x and y because it'd be confusing. It's going to call it h or k, right? It's going to be, so I'm going to call this h or k. So my delta x is going to be x minus h, my x value for my center point. Okay, and then y is going to be y minus k, which is my y value for my center point. Okay, so that is that. Okay, I should make that orange, I guess. It's highlighted orange. So that's that. Okay, so for this circle, it would look like this. So my radius is 5. So my radius is 5 squared. And it equals 2 polynomials squared. One is x, one is y. And my center point is going to be 4. So it's x minus 4 and x minus positive 3. Now keep in mind, if any one of these center points, if the center point is negative, you have to change, it's going to be minus a negative whatever number that is, right? And that negative will turn that into a positive number, right? So that is how that looks like. So if I'm given this equation and just this equation, and you'd be like, hey, what is that circle look like? You're like, oh, that is a circle with a radius of 5 whose center is at 0.4 and 3. And it's that simple. Okay? So hopefully that works out for you and you understand that stuff. Have a great day.